SpearAtlas was built for drone pilots and reality capture operators to store, organize, and send out their entire projects through one link. In today's video, I wanted to showcase one of the many features that SpearAtlas has to offer: measurements. Before measuring, I first need to make sure the model is scaled correctly. In the top right corner, I select Set Scale, then place 2 points across an object with a known measurement and enter its actual size. I typically use my drone landing pad when I'm able to capture it in the model because I already know its exact dimensions. SpearAtlas then uses that reference to set the scale for the rest of the model. But keep in mind, these measurements can be useful for estimates, inspections, planning, and general documentation, but a manually calibrated mesh should not be treated as survey grade. For higher confidence results, the model should be supported by verified survey control or a verified point cloud. Now, starting with distance, I'm measuring the width of this front section of the structure. And it's pretty simple. All you do is put 1 point on each corner and then it gives you distance. There's nothing much to it. No need to explain further. It calculates distance. Next is area. For this example, I'm tracing the perimeter of the main roof section. Here, I place points around each corner of the roof and then close the shape. SpearAtlas then calculates this into square feet. Here, it's showing about 1,081 square feet. Now we're on to the height tool. It is intended specifically for vertical change. Instead of measuring only straight line distance between 2 points, it isolates the difference in elevation. On this structure, the measured height is approximately 9.5 feet from the lower point to the roof line. Lastly, for slope, I'm measuring from the lowest point of the roof upward to the highest point. So SpearAtlas calculates this slope at 20.4%, and it also shows the rise and run used to calculate it. And to understand rise and run, it's pretty simple. You learn this in school. Think of it as a 2D graph chart, X and Y. X is your run, Y is your rise. You have to run before you jump. That is how it's used to calculate the slope. And an honorable mention is the volumetric measurements, which are currently blocked as of now due to being further tested and verified. If you're a commercial operator and you want to have a better way to deliver your projects, go to SpearAtlas.com and you can get started for free.